Good morning, everybody. This is John Handler speaking from Amazon Cloudsearch. I'm a solution architect on the team. Today we're here to talk about search, and especially search in the context of WordPress. When you think about search, you most prominently think about web search, where web search engines have indexed all of the content on the World Wide Web and then provide an interface for you to search against that, pulling pages for those searches. We brought out Amazon Cloudsearch, which allows you to accomplish a similar task, but against a collection of your own data. So for your own website, for your own WordPress content, for your own blog, you can take that content, put it into Amazon Cloudsearch, and then perform search on that content. So let's zoom in a little bit and talk about what is search. I think we have this wrong slide up. Here we go. So let's talk about the search problem itself. So again, we have a collection of documents which represent the corpus of data that you're searching over. And in an e-commerce setting for a site like Amazon.com, that corpus is comprised of a collection of products. A user would come to the site with a particular goal in mind. In this case, perhaps the user would like to buy a pair of shoes. They have a search box, typically, as well as sometimes some other user interface elements that allow them to communicate that goal to the search engine. And if they're using the search box and they type shoes, the search engine should then go and examine all of the documents that it has, all of the products, and pull up results that are relevant to that user's goal. So if I search for shoes, I might see some men's shoes, I might see some kids' shoes, some ladies' shoes, and possibly even a shoe rack. In all of these cases, these are textual matches for what the user has typed, but really what the right answer is for that query depends on what the user's goal is. And if the search engine is able to bring up the correct response for that query, then we win and the customer would buy a pair of shoes. Cloudsearch itself, as I mentioned, allows you to accomplish this task, and it does so as an AWS service, as a managed service provided by Amazon Web Services, and it really has a lot of the benefits of AWS built into it. In particular, you pay for the infrastructure that you need to support your use case only when you need it. So it elastically scales up and down and provides you with exactly the infrastructure you need. It's a low-cost solution. You can get started with, we like to say in guidance, up to 1 million documents and up to 30 or so queries per second for about $75 a month. You don't need to guess capacity. Within a search solution, one of the more difficult operational challenges is figuring out how many hosts you need to support the amount of traffic. And this is actually a challenging problem to solve correctly, and getting it right actually goes right to the bottom line to get the correct amount of hardware provisioned. With Cloudsearch, again, it's elastic. We provide exactly the resources you need for the search problem that you're presenting to us. With search, especially as you want to experiment, you would need to generally bring up new hardware. This can have a long lead time and make experimentation risky because you've paid up front for that hardware and racked it and put it in place. Cloudsearch is a managed service again. It allows you to deploy a search engine in about 20 minutes. You can experiment, you can take it down very flexibly with low risk. We do the undifferentiated heavy lifting. There's no need to go to the server, rack your own servers. There's no need to cable. There's no need to do all that. Cloudsearch provides that out of the box for you. And finally, with Cloudsearch, you can go global in minutes. We have presence in 5 AWS regions across the globe. You can push out your search engine to all of those different regions and have a presence around the world simply and quickly. I'm going to turn it over to Chris now from Voce Communication, and we're going to zoom in a little bit on searching your WordPress content with Cloudsearch. Chris?
Great. Thanks, John. Appreciate it. So, sorry. Go back to the agenda here. So I just want to cover real quickly who Voce is, why we decided we needed a better search for WordPress, a little bit on how we developed the Lift Search plugin for WordPress that uses Cloudsearch, and why we chose Cloudsearch, and then kind of dig a little deeper into how Lift works, and then installing it, using it, and then finally wrap up with a little bit of a case study on a client that we've integrated it with. So here we are. We're a team of about 20 developers, designers, user experience people. We typically build publishing systems for large-scale publishers, consumer products companies, and if you want to get more info about that, you can see us at voceplatforms.com. So why do we need a better search? If you have any experience with WordPress, you've probably come across the pretty basic limitation of the search. It's just a simple like query on post title and content. There's no weighting between either one of those. There's no advanced features that you get in a lot of things like Solr and Sphinx and Elasticsearch to do things like ranking and faceting. So really very basic. Also, in the default search, only posts and pages get searched, and there's an equal priority between the two. So what we typically saw is people would search on a site and they would be searching for what they thought was content that would be, kind of time-based content, typical WordPress posts, but yet pages would show up because of the title that somebody used in a page or the content of the page. For our clients, they want those pages to have less of a priority. They want posts to have a higher priority. Doing that with the default built-in WordPress search just was not feasible. So basically, the whole impetus for this is our clients wanted more. They wanted better relevance. So they wanted, when people came to their site, they do a search. They wanted the most relevant things typically to show up first. They also wanted custom post type supports. By default, we only get posts and pages in WordPress. A lot of our customers and clients, and also a lot of custom themes, especially those that you can buy on some of the theme marketplaces, they use custom post types to better organize information. So the users want those to be searchable. And then within that, also to be able to have things like ranking and faceting. So just a little bit on how we develop Lift, just brief overview here. We had clients come to us with the needs that they wanted for search. We had also, based on the experience we had with searching client sites to try and find content during development, after development, we had some ideas that we wanted to implement. So we started with a functional spec based on those needs, and then use that to create a tech spec, which was an outline of the implementation details. At that point, we really didn't have a hard idea of what we wanted to use for the back-end search provider. So we researched, what our options were, and then, decided on Cloudsearch in the end, but evaluated some other options there as well. We started it coding on a Monday. We had a team offsite, and then finished it on Friday for the initial release. That was about a year ago. Since then, we've seen almost 1,000 downloads on the plugin, and we've had some activity on the issues tracker on GitHub that people are using it and have questions about it, implementation questions, things like that. It's custom PHP. We didn't use any of the existing Cloudsearch or AWS libraries. We ended up rolling our own to work better with the way WordPress does stuff, with things like HTTP requests, so that we could leverage the WordPress framework and get the most out of it. We also use some JS, including Backbone.js in later releases, and then custom CSS for both the backend admin dashboard and for the front-end search forms and widgets. So why did we end up choosing Cloudsearch? We looked at a few other providers and really just in general looked at our requirements. And we didn't want our clients to have to host their own search instances. Our clients range from small companies to very large companies, and even just because you have a hosting infrastructure and IT infrastructure doesn't mean you have that infrastructure set up to run a search server such as Solr, Sphinx, Elasticsearch, something like that. Most IT departments just weren't set up to handle it. Also, it's fully managed. Many of our clients didn't want to have to manage that themselves. It wasn't their wheelhouse. They weren't particularly good at it. So we had a big win there with Cloudsearch, where we can have that be fully managed off premises and everything like that. Also, dynamic scalability is huge. So we have clients that have a lot of traffic in general, but also tend to do things around certain events that might have huge peaks in traffic in general. Also, we could then use that to leverage search for some interesting things as well, where we can use faceting to maybe display data on the site just based on that search facet. So we wanted something that could definitely scale there, both for the data we were going to send to it, as far as the actual search documents that were being indexed, and also query traffic for those cases where there was a lot of traffic to the site. Also, for our purposes as developers, Cloudsearch has a very easy API for both the search and document endpoints and the configuration endpoints. So a nice thing is we could do the configuration for the user without them having to use the AWS console to get these things set up. And then finally, relevancy was good out of the box, and there is the ability to fine-tune if needed. Just kind of one of the other things, a lot of our clients were already approved to use Amazon Web Services, or it was easy for them to get it into their organization. So even though there's no other AWS services required to use Cloudsearch, because they had already used some in the past or had an agreement where they could use Amazon in their organization, it made it easy for us to say, okay, well, if you use Lyft, you can use Cloudsearch, and we can get you started right away. So just a little bit about how it works. So after you install the plugin, the first time that you set it up, and we'll go through a little bit of how this works for some screenshots later on, and I'll show you what the installation looks like, the configuration, and the dashboard. But we'll just talk a little bit about it first. So when you do set up the plugin initially, what happens is a search domain gets created via the configuration API. So all you need at that point is your AWS secret key and access key to be able to get started. So a search domain gets created, and this is the same thing you do through the AWS console if you're setting up Cloudsearch manually. We just do it for you in the plugin. Also, a default document schema gets added. What we're doing there is we're mapping the WordPress schema to a document schema that Cloudsearch can use to index documents that we send to it. And then on the plugin initialization, we also add a WP cron job, which works across server types, so it doesn't rely on server. Gets added to queue all posts and pages that you have in your site for submission to the document service API. So that starts off the indexing process, takes all the existing content in your blog or site and sends it to Cloudsearch to begin being indexed. So just a little bit more about the document schema here. Just want to show kind of what we're indexing a little bit and what the differences are here. So this shows what WordPress post data over to a Cloudsearch schema. So if you've seen WordPress data tables or the WordPress post object, some of these will look familiar. Some aren't a one-to-one mapping. We have added some things to make some of the searches easier for things like author name and category and post names. So if you look through this table, I'm not going to go through every single one here, but just kind of want to talk about what some of these are. When you see default next to something like in the faceted and search column, what that means is that's the default value for that column for the type of data that it is. So if you look at the blog ID as an unsigned integer there, faceting is enabled by default for that. So that's not something that we're changing in Lyft when we send this document schema there. It's already part of the default. Same with that being enabled for search so that you get the results back in a search from Cloudsearch. That's enabled by default for a uint as well. So when you see default there, that's what that means. Result means that we're going to get data back from Cloudsearch of the search result. So you can index data, but you don't have to get that data back in a search query to Cloudsearch, which is nice because usually you don't need the entire document back. And what Lyft is doing is we're sending the document there for indexing, and then all we're getting back, among other things, but in the end what we really want back is a post ID that says, a list of post IDs that says these are the posts that match the search query. We don't need all that data to come back from Cloudsearch because we already have it in the WordPress database. So it saves a lot of time on round trip and data transfer back and forth. And then search means the field is searchable in there. So there's things like literal types don't need to be searchable for what we're using them for. All we want to do is be able to say, does this match? We don't need to search within the value. It's a literal value. So things like the taxonomy category ID and post tag ID there get sent as literals. Same thing with post status. No need to search within a post status because those are literal values of a few different statuses there. As you can see, we're indexing pretty much the most common things you would think as far as the post content, post title, post date. But then we also have additional things like type and status to let us do some faceting on, especially on the post type, to enable that as a facet. Also storing blog ID and site ID, so this will work with WordPress multi-site. And you can search both across sites within a network and also individually in sites in a network, and also those are enabled as facets as well. So when you get the results back, you can drill down through those facets if you need to. So a little bit more on how it works here with the document submission. So we said when we initialize the plugin that all the current documents in your blog end up getting sent to a batch, and those get sent to Cloudsearch for indexing. So Cloudsearch has a batch limit of, I believe, 100 documents. So we match that as well, and we create two batch queues. One's an active queue and one's a closed queue, meaning it's closed to new additions of documents to be added to it. So that way we can prevent race conditions in there. So if we're processing a queue, we don't have to worry about, are we adding documents to a processed queue and that would never end, or we're going to have some collisions there. And then the batches get run via WP cron as well. And you'll see in the setup screens here in a bit, that interval is user controllable. It's also controllable by, I believe, a constant that you can add to your WP config to change that on the developer side, but then the user could also change it in the dashboard. So anywhere from a minute on up to have documents run through there. So not only when we initialize the plugin and we send all the existing content does it get batched, but anytime you update a post, create a page, update a page, delete a page, trash it, change the post status, any of those types of data, same thing with post meta, those then get sent in a batch as well and indexed again. So that way you're always as up to date as you can be without it being completely real time. And then any document submission errors do get retried. If there's an error submitting a document to Cloudsearch, which really rarely happens in what we're seeing, that will remain in the queue, and then it'll just get processed the next time the queues run. So on the front end, when we search, when the user searches, there's really no difference for the user interaction. They have the standard WordPress search box, they enter their term, they get the results back. But what happens on the back end is we're hooking into the WP query to check for a search. And if there is, we then override that search, so we prevent it from doing the default search at that point. And we build a Boolean query from the term that came in from the WordPress query. That Boolean query is what Cloudsearch uses to search against a document index. So once we build the Boolean query, we send the request to Cloudsearch on the search API. We get the results back. And then in the end, what we're really looking at is a list of post IDs that are already sorted by relevance, by date, whatever parameters we passed in the Boolean query. And we then replace the WP query results with that. So we then run the standard WordPress query, but give it that list of post IDs. All this is transparent to WordPress, so there's nothing that needs to happen as far as any kind of coding or configuration. Lyft handles all that for you. This overtaking of the front-end search can also be toggled in the dashboard, which we'll see in a little bit. So if you do want to do some testing, so you want to see what it looks like before Cloudsearch and after Cloudsearch, you can toggle that back and forth, and you can see, okay, here's why this is working better for me. Here's some search terms that maybe don't work as well as I'd like, so I can do some tweaking on the Cloudsearch side and do some testing that way. So now I'm going to walk through just what it looks like on the installation and configuration, and then the dashboard screens. So plugin is free. You just need an AWS account to get started using it. And from there, all you need is in your account settings for security, you need your secret key and your access key. So you can download the WordPress plugin through one of the many standard ways. The easiest is if you have a server that allows write access, you can do plugins, add new plugin, search for Lyft, and click install plugin, and it'll be there. You can also upload it via SFTP, FTP, or do a code deploy, depending on your method of updating your site. Once you do install that and activate the plugin, you'll see a banner at the top of the page that reminds you, hey, Lyft isn't configured, you should do that now. Once you click that, what you'll see is the initial setup screen. This asks you for the Amazon access keys that I mentioned before and gives you some links to documentation on the on the AWS site. It gives you a little bit of information on pricing, which should match hopefully what John mentioned earlier. So after you enter your access key, secret key, and then click on the next, it'll ask you for a search domain name. And there's some help over to the right to tell you these are what the restrictions are on the naming conventions, and these are straight from the documentation on the Cloudsearch site. So if you look at those, this should match up. You create your search domain name in there, save it, and then you're done. So here's where I mentioned earlier, after you get everything set up, we go ahead and queue all the documents currently in your blog for submission to Cloudsearch. So that's now happening behind the scenes. So once you do finish this page, it refreshes, or if you go back to it, you then see the Lyft dashboard. So there's a few things there that you'll note. One is it gives you the status of your search domain. So if you look in the AWS console, there's a few different statuses on search domains depending on what's happening, whether they've just been created, whether they're being updated for things like changing access rules or things like that, or if they need indexing. That will also show here, so it gives you a little bit of a view without having to go into the console all the time. Also tells you on the document sync, so this is the batch queuing that I talked about before, when it was last updated and when it's next going to be sent. And then there's the adjustment for the queue interval there. So you can adjust that WP cron straight from this dashboard screen. Then you'll see under that there's that toggle to override the front-end search. So if you do want to do some testing or for some reason you need to disable it, you can easily do that there without having to uninstall the plugin or change any of your theme code. There's also an option to change your AWS keys. So sometimes that needs to happen for security reasons. You need to drop the ones you had. You can easily change those without affecting any of the other settings here. And then there's an option to just reset it. So that'll reset all the settings, clear out the queue. So especially when you're doing development locally or in a staging environment, you can reset it up, and then see, get it going again. And then this is basically what it would look like after you first initialize the plugin. And this has a list of all these existing documents to be synced. This will update based on that cron interval automatically. So we're using Backbone.js for this page, so it'll automatically update there. And you'll see that queue go down, hopefully in batches of 100 documents. And it's really quick to get those indexed. Once the queue runs, we're typically seeing a couple, 3 seconds for 100 documents to get sent to Cloudsearch and accepted. So now I want to move into doing a little bit of a little mini case study. So this isn't live yet in production. The site is, but the Cloudsearch integration with Lyft isn't yet live in production. It was supposed to go last week, and unfortunately we didn't quite get there. But the client that we did it for is Big Ten Networks. So they're an internationally distributed TV network. So you've probably seen them on your cable provider, and they're dedicated to covering the Big Ten Conference. Cover almost 1,000 sporting events, and the station's available in over 52 million homes. So what they have btn.com as their web presence. So they use that to promote and showcase content from the network, to provide scores and stats there, and also give viewers information about their digital TV product, the BTN To Go. So this is their web presence with it was a good candidate for Lyft and for Cloudsearch because they have a large number of both static pages that they use to organize content, as well as a lot of frequently created and updated time-based content. Because things happen, they're based on college football season in the U.S. They have things that happen prior to the season that they want to write about during the season, which is their peak publishing time, and then also postseason and kind of in that lull, they'll still end up publishing. But it's a good mix of very frequently updated content and also quite a number of static pages to organize their content that builds the structure of the site. So we noticed that the standard WordPress search wasn't giving them particularly relevant results for some of their common search terms, especially things like player names. So we worked with BTN to integrate Lyft and Cloudsearch into the site so that we could see, okay, does this give better results? And now we have some ability to do some filtering, some faceting, some tweaking. So this first implementation is fairly straightforward. So this is probably what most people would start with. And then from there, we could look at, do we need to tweak this? So, and the one thing I didn't mention here is This is the demo, the screenshots I'm going to show you here are just a subset of the contents. It's about 6,000 documents. It was using one small instance when we did the test, indexed very quickly, and we're ready to go. So one of the things I mentioned was that we have player names where typically the results weren't very relevant. So if you look here, here's with the little toggle I showed you before. Here's with the front-end search not overtaken. So this is just the standard WordPress search that you're seeing here. So a search for Braxton Miller, who's a player, doesn't really return a whole lot at first glance, especially that seems to be relevant for Braxton Miller. There's not a whole lot in the post content or the post titles there with Braxton Miller. Some of them might have Miller, some might have Braxton, maybe even in the excerpt. There's not a lot there, which usually the relevance, I think, as John mentioned, we're looking for, things that are repeated, things that are in the beginning of content, things that are in the title. We want those things to be more heavily weighted, which is something WordPress's search is not typically good at. So here we have a screenshot of what that then looks like with Lift enabled. So this is now using Cloudsearch for the results. As you can see, results are much better here. We have Braxton Miller in all of the post titles, which is nice. And we also have his name in the post content as well. So these are very highly relevant results for that search term. We've run a few other searches as well for players, for teams, for things like sports scores, and we're seeing consistently better results with Lift and Cloudsearch than we were with WordPress's standard search. And then if you notice at the top, we do have the filter by there. So right now we're only using one facet here. We're just using the publish date as a facet. The client wanted to start there and then see how we wanted to drill down from there based on some usage patterns. So we can then filter by date here. We've just added some default selections. So anytime, which is the default for just running a search. And then we can narrow it down 4 weeks, 2 months, 3 months. Especially during an active season, people are going to want things that are a little bit more recent. They might want to narrow it down, not go through as many pages of information. We could also then extend this later on with other facets very easily through the Lift search form and add those things that we might want to add, such as categories and tags as facets, so that people could then drill down once they do a search result for here Brandon Dawson. Then they can narrow it down by maybe they have a category that is interviews. So they could say, oh, I want to narrow down by the facet interviews and only see Brandon Dawson interviews. And then finally, I want to show what the just default Lift search widget is. So if you installed Lift on your site, got it up and running, it indexes your content, there's a search widget that you can add to your site that automatically gives you any facets that you have enabled. So here you'll see the same facets we had before for the publish date. And then we also have post type as a facet here as well. So we have post and attachments, or post and media, post type, sorry. So there's a custom post type on the site called media. And then also we have categories enabled as a facet. And here we only have the 3 categories. And the nice thing about Cloudsearch is when we get results back for any facet that's enabled in that document schema, we'll see a count of how many posts or how many documents, which in our case are posts, how many documents or posts match that facet. So it gives the user a way to say, oh, there's a lot of content here. Maybe I want to drill down into this first. And we could keep going with this idea of drilling down into categories, subcategories, so any hierarchical taxonomy is a good candidate for faceting. So I want to turn it over to John once again to talk a little bit more about how Cloudsearch delivers results.
Thanks, Chris. Really excellent to hear how Lift has really made integrating Cloudsearch with WordPress easy and available for everybody. I think we're going to switch gears a little bit and talk about Cloudsearch itself. And for those who are interested in taking up search or even just thinking about integrating search in WordPress outside of Lift, what that might look like. So if you're going to build search for your application or for WordPress, you have a few options available. The first is a roll your own kind of solution. You could use database search using the SQL-like statement. As we've heard, and especially in the context of WordPress, generally that doesn't give great search results. You could build your own algorithm and do your own indexing across your documents and try and bring relevant documents that way. Or you could use something like a site search that would integrate directly with your content. Apart from that, there are several open source alternatives out there that would allow you to deploy that software onto hardware, manage it, and build search based on your corpus. And finally, there are some legacy solutions that would provide, highly tailored, customized search for your application. But each of those has some challenges there to building search for your application. First of all, search is a complex problem to solve. The basic search algorithm itself is a difficult one to write, and it's difficult to build it in a way that would provide low latency, high throughput search. With Cloudsearch, we've really rolled up 10 years of IP into the search engine itself and taken all of the need for that expertise and brought it into in-house. Search, as we mentioned, is often costly with upfront expenditure in terms of buying hardware, racking it, provisioning that hardware, and getting it ready to serve your search queries. There's a long time to market. You can't turn the wheels very quickly. And all of that operational work is undifferentiated and really defocuses you from the core competencies in the core application that you're trying to build. Cloudsearch has been out for about a year now, and we've been providing search as a service, a managed service, to many different applications and across different verticals and use cases. So we'll look a little bit at the architecture and the interaction with Cloudsearch. When you get started with Cloudsearch, you build a search domain, and we've seen that in the context of the Lift plugin. The search domain itself wraps up two different services that allow you to do the work of search. So the first service is a document service where you would send the search documents that you want to search across, and those are batched up and sent as at most 5 megabyte batches. You use HTTP POST to send those documents to the document service. At the other end, we have a search service, and the search service allows you to use HTTP GET to send queries in the search URL and receive search results based on those queries. We support JSON and XML both going in and coming out. The domain is fronted by DNS, so it's a RESTful service providing these two document and search through DNS endpoints for you to interact with. In addition, we provide load balancing, security, and other features to protect across the search domain. Our third service is a configuration service, typically accessed through the AWS console, but also with command line tools and direct to API access. The configuration service lets you perform maintenance tasks like creating domains, deleting domains, setting some stemming, stop word, and synonym language options, and monitoring your domain. We have a full-featured search engine available supporting free text search, structured search, Boolean combinations, complex expressions. We allow you to do, we have a relevance ranking out of the box that is a text-based relevance. As well, you can customize that with integer values that you've placed into your documents. We support faceting, fielded search, integer range-based searching, alphabetic or numeric sorting, different weighting of fields so you can boost different fields in your relevance function. We have a visual rank expression comparison tool, which is really a nice tool in our console that allows you to look at an A/B comparison of two rank expressions. So as you're tuning your relevance, you're able to do that with much more ease. And we have some metric reporting that we also expose in our console showing you top searches, top 0 result searches, a search count, and those analytics and those metrics can help out, again, in tuning your ranking functions, in tracking how people are using your system, and making sure that you're providing relevant, good search results for your users. We'll just put up some resources, and then we'll turn over to the Q&A. There's an overview page for Cloudsearch where we have a lot of content and material talking about how to use Cloudsearch, pricing. We have articles, tutorials, walkthroughs, pointers to different videos where we've discussed Cloudsearch. There's also some pointers here for Lift, so where to get the plugin, some information about it, and the main GitHub page. So I think we're going to open it up at this point to Q&A, and we will take some questions.
So just as a reminder, if you'd like to type in a question into the question box, we will try to get to as many as we can in the remaining 10 minutes or so that we have with the webcast. So here's the first question, obviously a basic one around pricing, which is how much does it cost? So I guess this is a two-parter, John and Chris. Maybe, John, you could start with the Cloudsearch component.
Sure thing. So Cloudsearch pricing, first of all, there's information on Cloudsearch pricing on our Cloudsearch page, and you can get that from aws.amazon.com/Cloudsearch. Fundamentally, as I mentioned, Cloudsearch costs about $75 for up to 1 million documents and up to about 30 queries per second. Our pricing is based on the instance usage that you would use to support your search use case. So as you would push more and more documents in, you would see your instance size grow and eventually partition, and the cost would reflect that primarily. We also charge for batch uploads. We charge 10 cents per 1,000 batches, and we also charge to make configuration changes. You would have to run a full build. We would charge $1 per gigabyte of data. Chris?
On the plugin side, LiftSearch is a free plugin. It's open source. Sorry. LiftSearch is a free open source plugin. You can download it from the WordPress plugin repository. And yeah, that's the easy part.
Okay, cool. So here's another question. Is there advantage to using the plugin or Cloudsearch if the WordPress site is hosted in AWS versus outside of AWS? And then related to that, I think, is a question that we often get, which is, do you have to have all of your other types of services on AWS? Sure. John, maybe you could answer that one.
Yeah, sure. So within so Cloudsearch itself is offered as an AWS service, and as we discussed, it's a RESTful service that's available via HTTP and across DNS endpoints. So in and of itself, there's not too much advantage to running within AWS or outside of AWS. The one area where you might see some benefit is in the latencies that you would get if you were running in the same region as your Cloudsearch domain versus in the general internet. You would see improved latencies in contacting Cloudsearch, depending on collocation and those other points. To the deeper point, whether AWS usage is required for Cloudsearch, Cloudsearch does not require you to use other AWS services. So again, the service itself is offered as a RESTful service over HTTP endpoints. The source of the data and the source of the queries could be anywhere. It's free to use across the internet.
And I might add that it includes, within Cloudsearch, you really get the server capacity, the storage capacity, all the extra services that you would need just to run search, right?
Right.
Okay. Here's a question regarding maybe from some of the people outside of the U.S. and North America, which is what if content is in multiple languages? Do you want to deal with that one, John?
Yeah, sure. Cloudsearch at the moment supports English as our only language. And there are some workarounds that you can do. Fundamentally, the search algorithm is based on cutting up the words in the source documents into individual tokens. And then those tokens are indexed and matched for the search terms. The tokenization is based on white space and punctuation. So if you have other languages that are white space based, those languages will function fine in Cloudsearch. Cloudsearch supports the full Unicode character set encoded as UTF-8 minus a couple of illegal XML characters. And if your content is in UTF-8, Cloudsearch would be able to accept that content, index it, and search across it. The complication comes with languages where token segmentation is not white space only, typically Japanese, Chinese, Korean, or German. In these cases, it's possible to pre-tokenize and send that data into Cloudsearch in that way.
Thanks, John. Chris, here's a question for you, I guess. Is there any helper function within the plugin that would help improve search in the admin area for content editors to search relevant content?
Okay. Yeah, so one thing I think I forgot to mention is not only does Lift affect the front-end search, it's also, because it hooks in WP Query and we're not making an exception, it also does work on the admin side by default as well. So if you do have it set to overtake the search results from WP Query, you will also see the Lift results when you do an admin side search as well.
Thanks, Chris. Here's another one for you in terms of maybe some comparison to the options that are out there for WordPress search. How does it compare with Google Custom Search or some of the other plugins like Relevancy, for example? Maybe you could talk about some of the other alternatives that you looked at, Chris, and put it in context for us.
Sure. We've mainly looked at, we've had clients that have used Google Custom Search. Most of them didn't like it because of the Google branding, and then a Google Search appliance was usually cost prohibitive for them, and also required somebody to sit there and configure it for tweaking and tuning, or a large amount of money to get somebody else to do that. So Google, both the Custom Search and the GSA weren't really either to us or to our clients. Relevancy is also good. I can't speak specifically to its failings or to its benefits, but what we really did, our goal here for Lift was to make it as easy on the administrative user developer as possible to get up and running, and also give developers a lot of filters and some constants that they could set to where they could leverage all the internals within Lift very easily without having to dig through. So some of those things are documented fairly well. Some of them we're still working on getting documented there.
Thanks. Here's a question. Does the Cloudsearch RESTful API provide search metrics in terms of top documents, etc.?
So the services that we've exposed through the RESTful API are the document and search service. The metrics that you can explore are available right now in the AWS console. So we don't have API access for the metrics that we do expose in the console. Usually what we tell people is to log on the client side and then do the analytics there. Obviously, this is people have asked for this. This is something that we're tracking as a useful feature that people would like to have.
Okay. A question regarding updates. So how long does it take to upload content from a blog or a website, and then how long does it take to make it searchable? Do you want to start with Chris, maybe answering that generally for some of the use cases you've seen, Chris?
Sure. Yeah, typically what we're seeing is for a batch of 100 documents, which is the batch limit size, it's taking anywhere from 2 to 3 seconds to get those sent to Cloudsearch. So depending on how many documents you have, divide by 100, probably estimate about 2 to 3 seconds. The limiting factor there, excuse me, is the cron interval that we're using. So we're limiting that to a minimum of a minute. But I did a test the other day with about 6,000 documents. did it at minute intervals, and it was really quick to go. So your content will update quickly. There's also, if you have much more content, there are the functions that run on the cron job are publicly available. So as a developer, you could also create something through WP CLI or just a plugin of your own that would then continually loop through on a quicker basis. So if you had concerns about getting those there quicker, but really we're seeing as soon as we update content, once that cron interval runs, couple seconds, 3 seconds max, and a batch of up to 100 would get there.
Thanks. Question about how much control do I have over the ranking of my results, so the way that my results are displayed in response to queries. Maybe both of you could take a stab at that one.
Sure, Chris, you want to start out?
Yeah, I guess I'll take it from just the excuse me, the front end side when Lift's enabled, and then maybe you can take on how you can tweak on the Cloudsearch side. Sure. So on the front end, we have a search widget and also a form or a template tag that shows the search form. The search form filters that show under the standard WordPress search form. So those are customizable. Both of those are customizable by some default filters in Lift. So if you needed to add or remove facets from there, or even the values within those facets for things, especially when we saw the example earlier where there was a drop down to choose to restrict it by date, those could all be completely customized as needed through either PHP or even on the front end through JavaScript.
So looking at it from the Cloudsearch side, we provide, again, out of the box, a text relevance function that tries to match the query words with each of the document, and it scores more for rarer terms that occur often in a particular document. So a document would score highly if it has many rare terms within it. This is called TF-IDF, and it's a usual function for this. We also look at the proximity of the query words in the document, in each document, to compute a score based on that. So documents that have query terms that appear close to one another would score higher than documents that have them farther apart. The overall text relevance function is based on a combination of those two factors. Beyond that, we do have a function that allows you to boost different fields, as we've discussed. So we could look at boosting the value of a match in the title field, as we've discussed. And then beyond that, we also allow you to build what we call rank expressions. And these are algebraic expressions that allow you to mix not only the text relevance score, but as well integer values that are on your document. So for instance, if you have a time or a date stamp and you want to rank newer documents higher, you can construct an algebraic expression and place that onto your domain and rank by that expression. This is also fully customizable out to a query level, where during the query, in the query itself, you can define a rank expression and then rank the results by that expression that you've defined with that query. This is useful for doing things like user-specific boosts or user-specific search functions, including sorting based on geographic location, which is a common ask by people. All of that is documented in our Cloudsearch documentation.
Okay. Here's somebody that wants to get started and is wondering about, how would they handle test and development. So is there a way that they can get started at a low cost? Maybe John?
Yeah, sure. So we are running a free trial, and the first 30 days of Cloudsearch usage are free, and that includes the instance types and all of the other components of the pricing. So first 30 days free, easy to get started. We also have some canned data that you can deploy to a search domain. So if you're interested in just kind of kicking the tires and seeing how it works, if you go to the console and create a domain, as you walk through the wizard, you'll have the option to select an IMDb data set. You can select the configuration for that. The domain will come up. You can upload those documents. We have about 5,000 documents. You can play with test searches, all of that other stuff. So very easy to get started, very easy to see how it works, and also free for 30 days of usage.
Okay, and of course, Lift plugin is free as
well,
as Chris was mentioning earlier. I think we have time for one more question. This also relates to price. Could you have multiple search domain per instance if you wanted to use Cloudsearch for multiple low traffic sites to spread that regular monthly cost across these multiple sites?
Yeah, you can absolutely accomplish that. The way to do that is to place a field within the document that specifies which site the document belongs to, and then with your query, send a filter that restricts your search to just those documents. So you can co-locate all of that content within a single search domain, and then at query time you can select between the different sites to search only that site.
Good.
And Lyft supports that with the site ID and blog ID in that document schema, so you can get that out of the box.
Great. Well, thanks very much to our speakers, Chris Scott and John Handler. Awesome